In this video, we will talk about a unit circle. In order to measure an angle, we start from the x-axis and then we look at whether it's a clockwise or counterclockwise. If it's positive direction, in other words, if it's counterclockwise, the angle is positive. If it's negative direction, in other words, if it's clockwise, the angle is negative. For example, if the angle theta starts from the x-axis and goes to the counterclockwise and ends at the point P, then this angle theta will be maybe approximately positive 210 degrees. The other angle that starts same on the x-axis and goes it into the opposite direction, this needs to make up the whole circle of 360 degrees, so this will be 150 degrees. But be careful, since this is a clockwise rotation, this will be negative 150 degrees. Any point on the unit circle could be represented as x and y coordinates, x being the cosine of x and y being the sine of x. If so, on the first quadrant, the signs of the x and y coordinate will be positive and positive. On the second quadrant, it'll be negative and positive. On the third quadrant, it'll be negative and negative. On the fourth quadrant, it'll be positive and negative. Sometimes it is really helpful to know where the sine or cosine is positive and negative when solving problems. One quick, easy way to remember this is all students take calculus. All students take calculus. Take out all of the first letters on each vocabulary. All, that means everything is positive. S, only the sine is positive. Sine is a y value, so sine is positive. T, that means only the tangent is positive. Tangent, as we all know, tangent of x is equal to sine of x over cosine of x. So in this case, negative over negative will make it positive. So tangent is positive on the third quadrant. On the fourth quadrant, only the cosine is positive. So only the sine, only the tangent, and then a cosine will be positive. So this is one good way to remember. Equation of a circle is x squared plus y squared is equal to r squared, where r is a radius. As we saw it in the previous video, x is equal to cosine theta and y is equal to sine of theta. So replacing the x and y values on the equation of the circle, we know that equation of a unit circle, which means it has a radius of 1, it'll be cosine squared x plus sine squared x is equal to 1 squared, which is equal to 1. Equation of a unit circle could be represented as cosine squared x plus sine squared x is equal to 1. This is also known as a Pythagorean identity. This equation comes in handy when we're doing problems. Find the values of cosine negative 270 degrees and sine of negative 270 degrees. Let's plot where this is located at. Since it's negative, we know it is a clockwise rotation. 270 degrees. This will make it 90 degrees, 180, and 270. So that will be negative 270 degrees. The values of cosine negative 270 degrees. Cosine is an x value. So on this point, x value will be 0. If it's a unit circle, the y value, which is sine, will be 1. So cosine of negative 270 will be 0. Sine of negative 270 will be 1. For theta in radians, and k is an element of an integer. Integers are 0, plus minus 1, plus minus 2, and so forth. Cosine of theta plus 2k pi is equal to cosine of theta. Sine of theta plus 2k pi is equal to sine of theta. So let's look at this first two. If we are given a unit circle and given an angle measure of a theta plus 2k pi. So if we plug in k of 0, this will become 0. If it's 1, it'll be 2 pi. If it's 2, it'll be 4 pi, and so forth. And it'll be same for the negatives. We know if it's theta plus 0, nothing is happening. So it is what it is. The cosine of theta and sine of theta, that coordinate will stay the same. If it's 2 pi plus theta will be that angle theta plus 2 pi. 2 pi is a full 360-degree rotation, so we're going to end up where we started. So the coordinate of this will remain also the same. If it's 4 pi plus theta will be going around twice. So we'll start 1 and 2. Again, we end up being on the same place. So the coordinate of x and y will stay the same. That's why cosine and sine theta plus 2k pi will be cosine theta and sine theta. On the other hand, when we're talking about tangent plus k pi, instead of 2k pi, k pi is equal to tangent of theta. Let's look at y. First, create another table, k, and this time it's a k theta. So if k is a 0, we'll get 0. If k is 1, we'll get pi. If k is 2, we'll get 2 pi, and so forth. So with a different color pen, if we start at theta and we add 0, nothing is happening. So the tangent, which is a sine over cosine, will remain the same. If it's pi, theta plus pi is 180 degrees. So it starts it in here and we go 180 degrees. So we end up being in this exactly the opposite side. But remember, on this side, instead of being positive and positive, this is negative and negative. So negative over negative makes it again another positive, so this will stay the same. If it's 2 pi, we end up being in where we started. 3 pi will be full rotation and half more. So with the same logic of theta plus pi, the tangent of theta will remain the same. What if instead of P being on the first quadrant, if it was on the second quadrant? If it was a theta plus 0, this will remain the same. If it's theta plus pi, we end up being in exactly the opposite side. But remember, this is negative and positive. This is positive and negative. So when we plug in for a tangent of theta, which is sine over cosine, this becomes plus over minus, which is negative. This becomes minus over plus, so this becomes negative again. So it doesn't matter which quadrant we start with, as long as this is a full 180-degree rotations and its multiples, the tangent of theta will remain the same.